Um, uh, my name is Matt Copeland. I'm the sales engineer with Energy West Controls. It's my pleasure to introduce Rick LaRose, our presenter today. He is the product manager for the Nanobubble generator at Armstrong International. He has 30 years of plumbing and mechanical system design and installation experience. He is ASSE 12080 Legionella Water Safety and Management certified, and he is a licensed master plumber. Energy West controls air, steam, and hot air and hot water specialties, energy services and sealing products, along with process valve automation. Next slide, Rick. As you can see, we cover the Mountain West, Southwest, and Front Range territories. So if you have any questions, please go to our website. We can support you. Next slide, Rick. We also offer steam trap surveys and steam training classes. So lunch and learns or full day fundamental courses. Next slide. If you have any questions, please add them to the chat option or Q&A, and we'll have Rick respond to them at the end. I appreciate it. Go ahead, Rick.
Okay, sounds good, Matt. Can you hear me okay, Matt? All right, sounds good. Well, yeah, good afternoon, good morning to everyone that's joining. I appreciate everyone joining in. Looks like we got about 46 coming in now. Like Matt mentioned, I'm Rick LaRose with Armstrong International's Hot Water Group. And I focus primarily on domestic hot water systems and scale-related challenges the last couple of years, primarily around institutional buildings. My role is basically to support our engineering and sales folks like Matt and customers like you in applying our products, our digital hot water products, and most recently the Nanobubble generator we're going to talk about today. I appreciate Energy West setting this up, and I look forward to sharing with you guys. Just to level set what we're going to do here today, this is going to be a high-level overview of the Nanobubble generator, and the goal here is to spur your interest around this product so you have an understanding of kind of what it does and what it is. And then you would want to reach back out to Matt or one of your other Energy West sales men that are in the territory where you're located, and we can set up in-person meetings or further webinars to talk about this. So today's discussion, we're going to be focused today primarily on limescale, okay? How limescale forms in a domestic water system, and also we're going to touch a little bit on cooling towers. We're going to talk about how it impacts the system performance, reliability, energy use, maintenance, and what practical options are out there to address both existing scale, but more importantly, we're going to talk about how to inhibit new scale from coming back over time, okay? And this is important in facilities with hard water where mineral scale is, not just a nuisance, but really a system level condition. And like Matt mentioned, I'm a licensed plumber, and I live in Colorado, was a plumbing contractor for the better part of 25 years. So hard water has been near and dear to my heart for a long time, and I got to believe that everybody that's on this call today is interested in that and probably deals with a lot of the issues that we're going to talk about today. So I think that you'll find this a pretty interesting technology. We're also going to talk about how you apply this technology. Just at a high level, a nanobubble generator is a non-chemical, non-electrical, maintenance-free static device that can be installed into a domestic water system, and we're starting to apply them also to cooling tower systems to support gradual removal of legacy scale, but more importantly, long-term inhibition of new scale coming back. To give you kind of a roadmap of kind of how this presentation is going to go, we'll start by reviewing Armstrong International's Hot Water Group's 4 pillars of a domestic hot water system, of a healthy hot water system. If you are familiar with Armstrong and what we do, we really camp out on what we believe is a healthy domestic hot water system. And our commitment is When you trust Armstrong International with your hot water system, we deliver a complete solution, okay? So we're not so much product focused as we are system focused. And to do that, we break it down into 4 pillars just to kind of make it easy to understand. So we'll talk about those. We're going to review what is hard water, what kind of fundamentals exist around hard water. I'll talk briefly about what kind of traditional methods we've had to treat hot water and how they've worked or not worked. And then I'll introduce you guys to nanobubble generators and applications. We'll look at some drawings on how we would apply these to domestic hot water systems. We also have a solution for the cold water side as well. And we'll talk briefly about cooling towers, which are still, for us, an emerging technology. And then at the end, I'd like to show you a customer experience to show you how the technology has been applied successfully and what the outcomes were to kind of show you what it looks like. And like Matt mentioned, if you want to drop questions along the way in the Q&A or in the chat, if there's time at the end, I'll answer those, and if not, we can follow up. And one last thing here I want to kind of just set up for you guys is that everything I'm going to talk about today is going to align with ASHRAE and ASPE guidance, okay? Specifically related to how scale management plays a critical role in domestic water system hygiene and energy and things like that. So I like to reference back to those guidance documents and anchor our presentation in those. Moving on here, before we talk about the technology, let's talk about what a healthy hot water system, and when I say hot water, just so everyone's on the same page, we're talking about domestic water. So not building heating water, we're talking about domestic water. And like I was mentioning, we don't define this as a single component. A lot of people know Armstrong for our brain digital recirculating valve, which is best in class digital master mixing valve. But we really look at the whole system from the heater to the mixing valves to now with adding this nanobubble generator and then our Sage platform for monitoring and tying it all back together. So at a high level, a healthy system delivers hot water safely and consistently, maintaining stable temperatures throughout the whole system, and then minimize those conditions that promote stagnation and biofilm growth, okay? So with those ideas in mind, we can talk about those 4 core pillars that I was talking about: infection control, scald protection, compliance, and sustainability. And again, if you're familiar with us, if you've been in our other webinars, we tie our other products into these different buckets, and we talk about how our products individually and then also collectively as a system can support these different pillars. So today we're going to talk about how the nanobubble generator works in these pillars. So the first one is infection control. So from a system perspective, what we're talking about here is minimizing stagnation of the water, maintaining a consistent temperature in the water system, and avoiding low flow conditions that allow biofilm to establish and persist. And when this gets compromised, what we tend to see is biofilm development in the system on the scale, temperature dead legs, increased need for disinfectant. So like for our hospital customers on the line and our maybe even some of our hospitality customers, if you have an infection control issue, a waterborne pathogen issue, sometimes you're supplementing your system with additional chlorine and things like that. And that can really have a detrimental effect on your system. So we try to structure our delivery around not having to do those types of things, but still be able to reduce the Legionella risk. The second pillar is scald protection. And what this is we want to be able to deliver stable temperatures and predictable system response no matter what the demand on the domestic water system is throughout the day, okay? And so when the scald protection is compromised, what typically happens here is we get temperature swings, where maybe in the morning the water is too hot because overnight it got overheated and we have a scald risk, but then throughout the day, under demand, the system can't keep up and we have to adjust mixing valves and things like that. And those are all things that when you trust Armstrong and what we deliver, we don't want you to have to do those types of things. We want the system to work consistently, delivering temperature under any type of a demand. So these two pillars are pretty closely linked. When the system is struggling to maintain temperature control, then what happens is the temperature drops into the Legionella risk temperature zone, and we start to increase those types of issues in the system as well. So I say all that to help you understand that we want to look at all of these different pillars and tie them together to understand what your entire system is doing before we apply a product. The third pillar is compliance, which is kind of the mystical one. I'm just an old plumber, but this may be the hardest one for some people to understand. But what we're talking about here is more than just meeting minimum code requirement on day one, because most buildings are designed properly, the system is clean, it's operating, the building is commissioned, and so it starts out working the way it should, or at least that's how it should start out. But what we're talking about is having a system that can be operated, documented, and defended and kept running over a period of time. And especially when you add hard water, you start changing the dynamics in the plumbing system as scale builds up, which makes things kind of get out of whack. And we start ending up getting into reactive operating mode, spending more time fixing problems than preventing them. And we lose confidence on how these devices even work. The fourth pillar, the final pillar here, is sustainability. Sustainability, energy, conservation, things like that. We've been talking about this for many years. And what we talk about when it comes to domestic water is energy, as in the energy it takes to make hot water, whether that's coming from steam or natural gas or electricity, and then also water efficiency. How much water are we wasting down the drain doing activities such as overheating water to get it to the user on time, or having to waste a bunch of water that we don't need to waste. So we take both of those into consideration. And when this pillar gets compromised, obviously everyone on this call, if you're an end user, you understand that your bills just go up, you're using more energy, it takes more steam to make hot water, you're using more water. And then also, I also factor into this your chemical cleanings. If you're chemically cleaning your system or mechanically cleaning water heaters and stuff, you've got a lot of additional cost there that's coming as a direct result from the scale and the hard water. So just to wrap the pillars up, it's important to recognize these things don't happen independently. Typically what we see is as scale builds up in the system, there's something in each one of these pillars that gets impacted. And again, with all the different people that are on this call, from healthcare to hospitality to engineers to contractors and operators, and you each have your own pain point, and we're going to talk a little bit about kind of what those are. To understand why scale shows up, it's good to just do a quick little review on what hard water is. Hard water just simply refers to water that contains dissolved minerals, right? So primarily calcium and magnesium. And the presence and concentration of these minerals can vary pretty widely, depending on geographically where you live and what your water source is. But it's very common, right? And I gotta believe, we're here in the Mountain West. If you look at a hard water map, the Mountain West, the Midwest are very hard water areas. Typically around the Great Lakes on the coasts and things are not so much. And as I've launched this nanobubble generator and traveled for a couple of years across the United States, I see it widely vary. And so we're going to talk a little bit about this. The minerals themselves are not necessarily a bad thing, right? So minerals are good in water. We need to drink water that has minerals in it. Those minerals are good for our bodies. And in cold water, minerals aren't too damaging to our utility systems. Your water utility purveyor, the water company that you get your water from, they don't worry too much about that. They treat the water for bacteria and things like that. The challenge happens when that water gets heated up. And as that temperature increases, then the solubility of the calcium and the magnesium decreases. And when that happens, what happens is those minerals come out of solution. And you'll hear people say they plate out, they drop out. There's different terms for it, but essentially they leave the water and they go stick to everything and build up limescale inside your pipes, points of turbulence, water heaters. That's when it really becomes a problem, right? So over time, these things accumulate, and once that scale is present, it starts to drive all of the pain points that we discussed on those previous slides. So put a little structure around kind of why scale forms. It's good to understand how it's measured. Hard water simply means, like I said, the calcium, magnesium dissolved in water, and it exists kind of on a spectrum, right? So just so everyone understands, water hardness is reported in either parts per million, ppm, or sometimes us old school plumbers like to use grains per gallon. And so customers with soft or mildly hard water may not experience noticeable issues. But once you get into the moderately hard to very hard and you heat it up, that's when you typically have a lot of pain points. And those are the people that have been coming to us since we launched the nanobubble generator a couple of years ago. Those are the primary customers that have been coming to us, those with the hard to very hard water. And some customers don't really know what their hardness is, and you can get a water test or check your municipality to tell you if your water is hard or not, but really you're going to know based on your pain points, like that picture there you see on the left of that pipe that's got quite a little bit of scale built up in it. So when we're applying the nanobubble generator, we always want to qualify, do you have a hard water issue and do you have a lime scale issue before we move any further. The next thing I want to kind of level set before we get into the generator itself is to also help you understand that difference between hard water and corrosive water, okay? So hard water is scale forming. Those elevated levels of calcium and magnesium, and we heat that water up, those minerals come out of solution and they build up, they plate out, they stick to surfaces, okay? And that's the common problems are things like visible deposits. You can see the buildup on your faucets, you can see it in your heat exchangers. If you do a remodel project or you cut open a pipe, you can see the scale in the pipe. Those are the problems that we're talking about right here. Corrosive water, on the other hand, is material aggressive, okay? And this is often associated with low alkalinity, elevated chlorides, and aggressive disinfectants, especially if you're supplementally disinfecting your system, right? You got a little chlorine coming in from the street, but if you add additional chlorine, that can become very aggressive to your system. And those types of problems typically present as pinhole leaks, pipe thinning, staining, etching, premature failures of that type, okay? And this distinction matters because it's two fundamentally different problems. And the way I help our people understand it is scale builds up, whereas corrosion tears away. And if corrosion is your primary issue, a scale-focused tool is not going to be the right tool for you, okay? And the nanobubble generator is not going to be the right tool for you to deal with. So I try to help people understand that to keep them in the right lane and not try to apply nanobubble generators for corrosive water conditions. Now, I'm well aware, and I'm sure a lot of you are all on this call, that it's possible to have both conditions exist simultaneously as well. But what we're going to be talking about here primarily is domestic hot water systems and scale, okay? So again, when that scale starts to build up is long recovery wait times for hot water, temperature instability, and then when that scale builds up on those heat transfer services, like in your plate and frame heat exchangers or your tube and shell heat exchangers, you're going to be needing to do clean in places like with an acid or rid lime solution, things like that, or you're going to be replacing tube bundles and things like that. Those are the types of issues that we believe, and we've seen this nanobubble generator really help over time. From a maintenance standpoint, like I said, if you're doing stuff like this, if you're using a clean in place system to clean your heat exchangers, you've got a lime scale problem. If you've got strainers plugging up, valves failing, sticking with buildup inside of them, these are the types of issues. Isolation valves, as a plumber and done lots of projects, oftentimes we walk into a building to do a shutdown to replace a water heater or something like that. And you go to shut off an isolation valve and it won't close all the way because there's scale impacting the butterfly or the gate. I mean, if there's plumbers on the call, they're all going to know what we're talking about. So that's one of the cool things about the nanobubbler, that it's able to actually loosen those deposits and remove some of those. And we have customers that we'll share with you guys that have actually reported back to us that they've gotten those valves to work again down the line after they had been scaled up. So from a cost standpoint, obviously more input, gas, steam, those types of things cost you more as an end user. The CIP, like I mentioned, we've talked about that. Higher labor requirements because you're spending time fixing things that you don't need to fix. And then the replacement, like I mentioned, water heaters are expensive, mixing valves are expensive, all those components are expensive, and the downtime is expensive. So our goal with the nanobubble generator is to keep all of these issues from occurring, okay? So let's take a quick peek now. Let's transition into where would we put one of these domestic hot water nanobubble generators. If we look inside of there, what you can see is, these are the types of issues that we see where the nanobubbles can really work at both removing these existing scale deposits, whether it's an electric water heater element or shell and tube or a plate and frame. And the interesting thing that I've learned in doing all of this is that, a little bit of scale goes a long ways as far as energy consumption goes. And even, ASHRAE has come out and published that 5 grains of hardness, remember we talked about the different grains of hardness, 5 grains of water hardness can cause a 4% loss in efficiency and a 4% increase in cost of energy. So, the domestic water systems is not always a big energy hog from a consumer standpoint, but that's also lost capacity where your heaters can't keep up and maybe you're not providing enough hot water, or you're having to run multiple heaters simultaneously, whereas you could just run one cleaner, you start having to run multiple heaters to maintain load and things like that. So by keeping these heaters clean and keeping the scale off these surfaces, we can keep them running at their peak efficiency. So let's talk quickly here about what we know this is the problem. I think we've laid that out for you pretty well. What have we had in the past to deal with these types of issues? And the gold standard is basically water softening, right? Water softening, or in a boiler system, reverse osmosis if you really want to polish the water up. And both of those work by removing the hardness minerals from the water, right? And when they're properly designed and maintained, these approaches are very effective at preventing scale and offering predictable performance, right? The trade-off is that you need to have, a dedicated water softener, some space for that, and then the ongoing salt replacement, and then the membrane maintenance, the water usage, the backwater usage to flush those out, and the operational oversight. We're not here to say that you shouldn't be softening or anything like that, but softeners have, a place, and they can be a maintenance nightmare. Oftentimes I see them just turned off. People don't want to mess with them. They don't want to deal with them, right? The next one I want to just talk briefly about is electrostatic and magnetic conditioning devices, which are a non-chemical approach they're designed to influence how scale forms and adheres. The appeal is they're simple, they're usually not very expensive, there's minimal infrastructure, but the performance can vary significantly depending on water chemistry and system conditions, and the results are not always very consistent. And me, I've been a plumber for 35 years. I've seen many of these products come and go. Some of them have worked and some of them haven't. And I'll tell you that Armstrong International, we've been around 120 years. We've looked for something like this because our water heaters scale up just like everybody else is doing hard water condition, and we've evaluated some of these technologies and never felt confident endorsing them until we came to the nanobubble generator. Clean in place, CIP, chemical cleaning, is another way. Now this is right? So the first 2 strategies were kind of an inhibition. Let's try to keep the scale from forming. The CIP is like a reactive strategy. Now my heaters are scaled, my system is scaled, I got a problem, I got to shut it down, I got to hit it with some acid to get this scale out of my system, get this heavy fouling done, which it works great. Ridlime is a wonderful way of removing scale quickly from a scaled up heater, but you do have to consider that you're handling chemicals and what are you going to dispose of those and things like that. It's a reoccurring expense. That's maybe not predictable. You don't know when that's going to scale up and you're going to have to do it, or it's something that you're doing on a regular PM basis. I mean, we have customers that come to us and say, hey, everything from, like I said, out in Iowa, every 2 weeks I got plumbers running around blasting these heaters out in these college campuses, to every couple 3 months, to every annual. So our goal with the nanobubble generator, and what we're starting to see with customers, is the ability to just get away from having to do that type of maintenance on a regular basis by keeping the heaters from scaling. So we're going to transition now and talk about nanobubbles. Kind of what you all came to hear about is nanobubble conditioning is a non-chemical approach, but it works different than those other ones. Rather than removing the hardness and aggressively stripping the scale, nanobubbles continuously condition the system. Okay, so I want you to kind of keep that in your mind, that this is a conditioning that's going on. And what makes them distinct is that when we do this right, they gently remove the existing scale over time, and at the same time, and again, this is where the power is, they inhibit new scale from forming. Okay, so it's not a replacement for like your ridline cleaning. Okay, this is not something where if you called me and said, hey Rick, I got my heaters completely scaled up, I got no flow through it, let me slap a nanobubbler on there and in 3 hours this thing is going to be clean. No, I'm going to tell you to do a CIP with ridlime and clean it up. That's not what this is designed to do. Okay, what this is designed to do is take a clean system and keep it clean. The nanobubbles will remove scale over time, okay, and we've seen that happen. And the timing can be all different. We don't know how thick the scale is in your system. I've seen it from days to weeks to months of time, but it will remove legacy deposits. But the real power is in its ability to inhibit it. So we position this as a maintenance and conditioning strategy rather than a immediate removal of scale strategy. So let's talk about nanobubbles briefly. I'll give you a basic introduction to what nanobubbles are. And again, my goal today is to kind of wet your whistle on what they are, how we make them, and why they're good for scale. Well, I can't answer all of the questions and all of your ideas, but I want you to kind of have a basic understanding of what they are, and then we can follow up and work with Energy West and get your other questions answered. But essentially, a nanobubble is a microscopic gas bubble that's suspended in water. Okay, they're thousands of times smaller than a visible air bubble, and they behave completely different than air bubbles. Okay, instead of rising to the surface, you know, if you think about air and water, it typically just rises and is vented off and it's not useful. Nanobubbles actually stay in solution and they travel around with the circulating water. They're very robust and strong, and they have a tremendous amount of energy inside of them that can be used on the scale. Now, the way that we make them with our generators is we make them through a process called shredding and cavitation. So we shred and cavitate those already present non-condensable gases that are entrained in the water into nanoscopic bubbles, and then that water continues to flow through the generator, and as it passes through the generator, with every pass, more non-condensable gases are shredded and cavitated into nanoscopic bubbles. So there's no compressor, there's no blower, we don't have any external gas source. If you Google nanobubble generators, you'll find other generators out there that add gases and things like that. We use the existing non-condensable gas. This is a physical change to the air that's in the water. That's it. We don't do anything to the water molecule, to anything like that. All we're doing is changing the air that's in the water. Okay? And this thing is working continuously as water is being passed through it. The cool thing is that the bubbles remain present throughout the whole system, and they're microscopic, so they go everywhere, into every little nook and cranny, every little valve seat, every little place where they can, to both kind of remove the scale, but then keep the scale from forming back into those little places, precipitating out. And over time, this just basically cleans the system and keeps the scale from coming back over time, okay? Now, the way that nanobubbles inhibit scale adhesion and growth, okay, is that essentially at a very small nanoscopic level, these nanobubbles carry a negative charge, okay? So they have a negative surface charge on the outside of them. Scale-forming minerals that are in your hard water, remember the calcium and the magnesium, those have a positive charge. And so what happens is the nanobubble the system and they interact with those minerals and they weaken their ability to cling to pipes and heat transfer surfaces. And what happens is the minerals actually cling to the nanobubble and stay in solution. And then over time, this interaction helps loosen up the existing scale as well and makes it harder for that new scale to build up, okay? And again, there's more science to be said on that. I don't have time to go into all of that, but in essence, that's kind of the basics of it. As far as our generators, like I mentioned, water passes through these, and there's basically a series of precisely designed chambers that create vortices and pressure drops that transfer that gas, transform that gas into nanobubbles. This is a patented design. We have a patent on this. And no electricity is required. There's no maintenance. It's static mixer. It's all 316 stainless. There's no moving parts inside of here. And the smallest opening is only 1/8 of an inch, so these don't clog up or anything else. The only net requirement is that they do introduce a 5-pound pressure drop. So as water flows through them, there's a 5-pound pressure drop from the inlet to the outlet. We talked briefly about biofilm, but I just want to hit on this, that we had customers come back to us and ask us, hey, can these nanobubbles remove biofilm? And we did a study with Montana State University's Center for Biofilm Research and Engineering. And basically what we concluded in that study was that when you have biofilm occurring with scale, which is very common, if you have biofilm in your system, oftentimes you have scale. As we removed that scale with the nanobubbles, the biofilm came right with it, and we had a reduction in colony forming units of bacteria after using nanobubble treatment. Okay, so we don't sell, there's no silver bullet for Legionella. We don't sell promote the nanobubbler for Legionella, but when it occurs with scale, we did see very favorable results. I'm going to try to go a little faster here and kind of get through the application side for you guys in case we have time for questions. But essentially, I want to just talk about why domestic water systems are the ideal candidate for a nanobubble generator. And first of all, we have water continuously coming into the system. And again, that water has non-condensable air in it from the street. Okay, so that fresh water is constantly coming in. Obviously, it's constantly bringing in those minerals, which are the problem that we're trying to solve, right? The other key element that domestic water systems have is they have a drain. There's a drain where the water leaves the system so that those minerals can then leave the system. So again, we bond the minerals in solution, we keep them in solution, and they just flow right down the drain, okay? So we need both of those things to exist. Also, domestic hot water systems domestic water has all of the proper gas that we need to make nanobubbles. So we're taking the oxygen, the nitrogen primarily, some carbon dioxide, and we're making nanobubbles out of that. The other key element to a domestic hot water system is that it's a continuously recirculated system. Remember, I showed you that generator, and essentially we want water continuously flowing through that because the nanobubbles get used up. They break, they bond, and they get used up in the system. So we want to constantly be making them. And the domestic hot water recirculation system is the ideal setup for making nanobubbles continuously. Okay, so over time, the repeated interaction is going to promote gentle loosening of the existing scale, and then the whole system is going to keep new scale from forming up, and whatever gets suspended in solution is going to flow just right down the drain. Okay, so let's talk about where we put these in a domestic water system, right? So basically, in over roughly 90% of all of our domestic applications that we have to date, the generator is always installed on the hot water recirculation return line as is shown here on the discharge side of the pump. Typically, in what we call a side stream, this is what we call a side stream piping setup. It's a very simple setup where we direct a portion of the stream through the nanobubble generator using a balancing valve. We use the existing pump, or if it's a new system, a new pump, to drive water through the nanobubble generator. The location is intentional because it gives us three things. We've got that continuous flow. We've got the pumps pumping all the time. You should always be having your domestic hot water pumps running all the time. And then we're constantly making the bubbles. The bubbles are doing their work, and then they're going down the drain when you open up your faucets and the water flows to drain. Okay? So again, the only thing that you have to keep in mind is that that pump is going to need to generate an additional 5 pounds of head pressure at the proper flow rate for the generator to work properly. There are situations where you may not have a recirculation return, like we have apartment buildings and dormitories who came to us with point of use water heaters. Also, industrial customers may be in a wash down situation. But if you're considering doing something where you say, I want to do a one pass through type of a setup where water comes in, it gets nanobubbled, and it goes out, what we've got for that is what we call a super saturator. And in this configuration, essentially what we've got is a nanobubble generator paired with a storage tank and a small dedicated recirculation loop. And in this case, we're looking at it on an incoming water service. So essentially where the water comes in the building, we put this setup in. It's important to be clear that we do not install nanobubble generators directly on the incoming water service. Installing it directly on the water service would introduce pressure drop, for one, which would be a negative impact to your down. Plus, we want that continuous recirculation to build up bubbles over time. By doing this situation, what I'm showing you right here, the super saturator, we avoid all of that entirely. The incoming water service always remains at the proper pressure, and the generator operates on a dedicated circulation loop where flow and pressure can be controlled. The purpose of this approach is different than the hot water recirc return. So the way that this works is during off-peak periods, so at night or low demand area times, the system runs continuously concentrating the tank with nanobubbles. Okay, so we build up a very high volume of nanobubbles in the tank. Then during the day, as water is drawn through the tank and out to the building, those bubbles head out into the system through the cold water system. So wherever that water goes, if it goes to a point of use water heater, or if it goes to a cooling tower makeup water, or wherever that goes, the nanobubbles are going to go with that cold water, and they're going to treat that whole system. This is really a great setup if you don't have, like I said, recirc return, or I've even been promoting it for older customers with older buildings, or maybe you have unreliable recirculation, or maybe you're trying to set your domestic hot water recirc pumps back for energy, because no recirc flow means no nanobubbles get made. So this could be a solution for a setup like that. So I'm going to kind of wrap up here and talk a little bit about cooling towers. So cooling towers are another application where nanobubble conditioning can be used, but it's important to discuss this at a high level, and I want to set the expectations with you. Before getting into kind of showing you the diagram, I want to add some context to this. Like I said, we entered this space specifically targeting having this for our water heaters, for Armstrong's water heaters, for our customers who are having hard water issues. But what has happened over the last couple of years that we've had this on the market is customers have come back to us and said, hey, the domestic water is a pain point for us, but cooling towers and a chiller condenser bundle fouling is more of a big deal to us. And so we've started evaluating that. We launched it for the domestic water, but we're starting to this year evaluate it for cooling towers. All right. So the good news is there's some good news and some bad news about cooling towers, and it's not necessarily bad news, but it's just things that we have to keep in mind. The good news is they're open loop systems, so we have water continuously going in, and they're being blown down. So we got a way to get rid of the scale as well. So both of those conditions exist, which is a very good thing. But there's also some challenges, okay? This is the way that we've been doing them. We've been installing them on cooling towers this year. On the left, you see the tower there in the sump basin. And this is very basic. Your system is going to be more complicated, but from a basic standpoint, we just install them on the condenser water loop using the differential pressure between the discharge and the suction side of the pump. That's the simplest and easiest way to do it. There's other ways to pipe these, and again, this is just to kind of wet your whistle. If this is really interesting to you, you can definitely reach out to Energy West. I talk to customers every single day about this, and we're applying these. But this is a pretty easy approach. It's minimally invasive. You don't have to shut the whole cooling tower system down and things like that. The variables that are present that are more challenging, okay, and being very clear and transparent with you guys, is things like the chemical treatment programs, how you're running your cycles of concentration, biological control requirements, regulatory requirements, and seasonal operational changes. I know like in the West here, a lot of our customers like to run economizing. They don't run their towers in the winter. And so there's some different variables of how these systems work that we're monitoring, and we're working with customers to understand how to properly apply the nanobubble generators. Again, being very transparent with you guys, this is emerging application where we're still developing what the best practices are, and we're doing this by working with customers. And for everyone that's on the line, Armstrong is definitely interested in partnering with customers on doing structured trials on cooling towers and validating those. So if you're interested in that, reach out to Matt or the Energy West guys, and we would love to kind of work with you guys on that. So let's talk about the product just real quick of what we offer for generators. They come in different sizes, and basically the size is based on the flow rate. Okay, we sell individual generators. They're threaded or 150-pound flanges, and they, like I said, they start at 3/4 inch, which is a 1 to 5 gallon a minute, all the way up to a 6-inch model, 1,200 gallons per minute. Then we also offer these as a complete prepackaged, prefabricated side stream. This is a really great setup for a domestic hot water system, where basically you just cut 2 pieces of pipe, you drop this in, it's got your balance valve, it's got your differential pressure gauge, your strainer, everything you need to kind of just drop it in and go. And so we have those just as a product unto itself. So you could pipe it yourself in the side stream, or you could buy a complete package. And I'm going to wrap up here with talking about this customer, and then we'll look at the questions here in a second. So basically, this is a customer journey from a big major Big Ten university out in the Midwest who had a really difficult hard water problem. Okay, they did big campus-wide water treatment efforts. Okay, so this is a big campus. They have a huge water softening plant in the main water entrance into the campus, and they're able to soften the water some. So if there's any big campus people on here, sometimes you're able to knock some of the hardness off, but maybe you're blending or doing different things. So essentially what they were ending up with was by the time the water got to the dorms, out to the campus, it was still a persistent problem of building up scale in heat exchangers, where they were having to clean these heat exchangers like I was showing you, those rid lime cleanings, those clean in places, every 3 to 4 months. Okay, they were having everything, aerators and strainers were getting clogged up. The pipe, the interior diameter of the pipe was getting smaller and smaller from the scale being built up, which is causing balance problems and all kinds of different things. So what they did was they were skeptical. I mean, a lot of customers come to us and these magic bubbles, this doesn't make much sense to me. I was skeptical as a plumber. I had to really really work this out myself and see many customers now have success. And I'm sure there's a lot of people on this call that are skeptical, and we totally understand. So what they did was they said, we'll just do our own test. So they put one in on the domestic hot water. You can see it there in the center. It's just a small 1 3/4 one on a dormitory. And essentially, they did their own test. They opened the pipe up and they looked at how much scale was built up in the pipe. They installed a set of bag filters, and we recommend this if you're doing a trial. They put a set of bag filters in to kind of collect that scale over time. And they looked at that and evaluated that. And what they saw was, from a removal standpoint, you can see they started out here after about a month in, they had about that much buildup on the left. By about 4 months in, it had took about 25% of it away, and then by about the 8-month mark, it had taken about 80% of the way away. And they had similar results with their mixing valves and their water heaters. They opened up the heads and looked at their water heaters and saw similar results. But again, the major win for this is that the scale's not coming back. It's being removed slowly, but the bigger win is that it's not going to come back. And so customers like this, other universities we've had, they put these on brand new buildings where they have know that things are going to scale up down the road to kind of get ahead of the problem and keep it from coming back. So with the time left, I just want to wrap up and tell you that, the main points here we talked about is scale, right? So if scale is your problem, this is something that you may want to take a look at. The nanobubble conditioning is a long-term strategy, okay? This is not maintenance utility plumber's thing that he throws in his truck and goes out and blasts your system out. This is a device you install in your system, and it gently removes the deposits and inhibits stuff long term. This is not an emergency recovery. It's not designed for heavily fouled equipment. The third thing is that the domestic hot water is pretty much the benchmark application that we've been putting these on, okay? And we're interested in cooling towers. That's a logical next step for us and something that the industry has been looking for. But we want to be clear that this is emerging application, and we're approaching it very deliberately with structured trials and coordination and doing water treatment programs and things like that to understand it. And again, this is a recirculated setup. We want these to be recirculating consistently over time. So I know I hit you guys with a lot of different things. I'm finished with the presentation portion of this. So we do have, I think, a couple of minutes here to, if there's some questions, Matt. I don't have the ability to look at the questions on my screen, but
Yeah.
do you have any questions
Rick,
that I can answer?
I'll read them off to you. One of the questions was, will the nanobubbles cause the spray heads and media on a cooling towers to be plugged up? And can these bubbles cause harm to humans?
So two questions I think I heard. Will nanobubbles impact cooling tower spray nozzles, emitters, things like that? So like I said, we don't have any data points to say one way or the other on that particular front. Where we have these installed on cooling towers, we have that be an issue, but I do not have any other data beyond that. Is that no, the bubbles are not harmful to human beings. Again, all we're doing is taking the big air that's in the pipe and making it smaller, okay? So nanobubbles themselves are not hazardous to health. And again, if you Google nanobubbles, just Google nanobubbles in medicine, and it's crazy. You'll see things like they use nanobubbles to deliver medicine in the human body. So no, they're not. And we've done our own independent lab tests and things like that to validate that. So no, they're not toxic or harmful.
All right, another one is, can you use this on a condensate return line?
Okay, so sure. And we get asked that a lot. And here's where we're at with that. And I'll talk about condensate as well as a couple other things that I'm sure people will be asking. Remember the conditions that have to exist for this to work. Okay, we need fresh water constantly coming in with non-condensable gas. We need a place for that stuff to go later. Typically in a condensate system, you don't have that. Especially, you're deaerating, you're trying to get the air out of condensate. The chemistry of condensate is not conducive to nanobubbles. And also nanobubbles, as you approach the flash point as steam, nanobubbles are history, and they don't work. So we don't recommend nanobubbles for condensate. We don't recommend them for boiler feed waters, for hot water boilers, for steam boilers. We also don't recommend them for closed loop boiler water systems or closed loop chill water systems. I'm sorry, believe me, I wished that was the silver bullet that I could give to you, because I understand that problem. But again, we don't have the proper conditions, okay? And so they're not recommended for those, only for domestic hot water, cold water, and cooling towers.
Will a nanobubble help reduce scale problems in a large residential house in the Mountain West?
Well, if you've got enough money, I suppose here's the thing though, is maybe a supersaturator could do that. We do get asked, people are interested in it from a residential standpoint. I mean, it's a commercial product designed for a commercial application, but yeah, if you circulate it and put a supersaturator in your house, it would definitely provide that. I mean, but that's a chunk of change.
Is there a certain ppm oxygen needed, given that hot water drives off dissolved gases? Wondering how you know if there's enough gases in the water and how you can monitor the performance.
So we validated that, and that's a great question. We validated the device. We worked with Clemson University, and we validated the device up through 200 degree water. So our digital flow water heaters, we overheat the water in our heaters, and we make 200 degree water, and we have successfully built nanobubbles in that environment and had them work on our heaters. So we're good up to 200 plus degree water. You know, if you get into high temp hot water systems, you know, 350 degrees at 250 psi, we don't have any experience there, but we know that they work well in traditional domestic hot water systems, 140 all day long, 120 all day long. And again, this is not necessarily based on validating the bubble population, it's based on validating the scale removal and inhibition over time. Good question.
Yeah. What is the life expectancy of a nano generator?
So it's all 316 stainless, it's all welded construction. So it comes with a 5-year warranty, but there's no moving parts in there. Like I said, the openings aren't tiny, it doesn't need to be backwashed. I would expect that to last as long as the life of anything else in your plumbing system. I don't foresee there being any of those coming back.
All right. Could you use a conductivity measurement upstream, downstream to continuously monitor the performance? Meaning if scales being removed, you'd assume the conductivity would increase on the downstream side of the nanobubbler.
We have not done that. What we do see is when we do startup and we do validation, we also do water chemistry analysis. And so what we do see, the cause and effect of it is, for instance, the hardness of the water increases as you release legacy scale into the water. What we see is increases in calcium, increases in magnesium. So we've more approached it not from a monitoring, but more from a evaluate the water chemistry, but that's an interesting idea.
Does the nanobubbles get affected if water pressure changes?
Definitely, you know, everything follows Henry's law, and so you know there's definitely some impact there. Exactly what they are, I can't tell you that level of science. But again, we base all of the performance on the results, okay? And we've seen good results in a standard domestic plumbing system. So we get asked regularly for all kinds of applications for nanobubbles. Hey, can it do this? Can it do that? And if you look online, you'll see other people using nanobubbles for all different kinds of applications. Again, our position is domestic water and possibly cooling tower systems. We've had great success. We've been on the market for 2 years now with it commercially in the States. Prior to that, we had 8 years of R&D, both with the University of Clemson and Montana State, and then also in situ in customers' facilities. And again, me, the old school plumber, that's where I had to see it work and see customers actually show us the insides of heat exchangers and pipes to see the performance actually validated out.
Have you implemented this technology in a heavy industry application like a copper smelter plant?
You kind of cut out there, but we've mostly, the majority, like I said, 90% of these have been institutional, commercial, universities, hospitals. We have a few in some food plant applications. A lot of interest in the industrial side, but we're not opposed to that, but we need to understand the system dynamics to make sure that the right conditions and the right problems exist for this to be the right application.
All right. And is there a pressure drop using the nanobubbler technology?
Yeah, so essentially there's a 5-pound pressure drop, and in the IOM on our website, and I would invite everybody to go to Armstrong International's website and go to the nanobubble generator page, and there's a lot of resources there. There's a bunch of videos from customers and testimonials of what they've had, and there's also the IOM, and in there is a pressure drop chart that kind of shows you at various flow rates, but the minimum where we like to run these is at a 5-pound pressure drop.
Oh, here's a good one. Can we install one of these at CU Boulder as a test bed to see how they work over time?
Absolutely. On what? On a test bed? Well, we could talk about it. I'd have to understand a little more about what we're interested in different applications, but we need to talk about it.
But we do. What are the offerings from Armstrong in regards to a trial?
So we do a couple of different trial programs. Everything runs through Energy West for our local reps, but we do different things. We do a delayed billing option, so that we have some delayed billing programs going on right now, basically kind of a try before you buy type of a program. We also have a discount program. If your first one If you want to try one out on a discount, we can do that for you. I mean, it's a seeing is believing product. Believe me, I'm probably not talking anybody into this, but you really do need to install it. But we do the trial programs. We have you install filters so you can validate it, and we can do water chemistry reports, and that's a good way for customers to kind of validate it. And I can help you guys with all of that and kind of show you what other customers have done to validate it for themselves. But yes, we do.
Great. I think that's the rest of the questions. Thank you, Rick, and everybody for attending. If you have any questions, please feel free to reach out to Energy West Controls, your local sales engineer. Anything else, Rick?
No, I appreciate it. Thank you guys for listening. And like I said, if this has kind of piqued your interest, reach out to Energy West Controls. They can set something up. I travel the whole country and work with customers. I'm actually in Texas working with a customer today who's been running a generator, and I'm happy to talk about your applications and share more results and success. I understand that this is a skeptical technology, but appreciate you guys' interest, and have a wonderful day.
Thank you.
Bye-bye.